Look at the sheer scale of modern ambition. Today's skyscrapers and massive infrastructure projects are marvels of engineering, demanding millions of parts, thousands of workers, and absolute precision to get off the ground. But despite these towering designs, the way we actually build them hasn't changed much in decades. The industry still relies heavily on muscle and sweat, with workers executing grueling physical labor at extreme heights using time-tested, highly manual processes. This reliance on physical, hands-on methods creates a massive invisible problem: data fragmentation. Crucial project information ends up trapped in silos across disconnected departments, making it incredibly difficult for different teams to access the numbers they need when they need them. These traditional methods have finally hit a wall. Relying purely on physical labor and disconnected planning is no longer a viable way to manage the massive, complex demands of the modern world. The industry is currently facing a severe labor shortage. Experienced veterans are retiring in droves, and there simply aren't enough young, skilled workers entering the field to take their place. At the same time, the cost of raw materials is rising steadily. Combine that with frequent project delays and strict new demands for eco-friendly building practices, and traditional profit margins are effectively eroding. To manage this escalating chaos, construction firms are deploying artificial intelligence as a digital nervous system, integrating scattered data points to bring order. For an industry squeezed by these economic and physical pressures, AI is becoming a core requirement for maintaining project viability. Before ground is ever broken, a project has to be planned. For decades, this meant relying on static 2D blueprints and manual drafting tools, which offer zero adaptability if conditions suddenly change. Now, planners use Building Information Modeling, or BIM, augmented with AI. This technology generates a 3D digital wireframe of the project and automatically scans it for architectural clashes, like an electrical conduit running straight through a structural steel beam, long before a single brick is laid. This is a direct look at the financial impact of the technology. In one recent case, an AI-assisted BIM system caught a structural conflict that saved a project $500,000 in physical rework costs on a single error. Beyond the physical structure, AI software also tackles the timeline. By analyzing historical project data, current resource availability, and even weather patterns, these systems optimize schedules and have been shown to reduce project delays by 30%. This virtual build phase ensures that inevitable mistakes happen in the digital realm, where they cost absolutely nothing to fix, rather than out in the physical world where they cost everything. Eventually, that pristine digital blueprint has to meet the mud, noise, and chaos of an active, highly unpredictable physical job site. This chart illustrates a steep 20% drop in workplace accidents on a site using AI-driven computer vision. These continuous visual systems scan the environment in real time, identifying severe safety hazards and alerting supervisors to intervene before an injury actually occurs. That same predictive logic applies to the heavy machinery itself. Complex mechanical components have countless hidden failure points, but AI monitoring systems analyze engine data to predict machinery breakdowns before they happen. By scheduling maintenance exactly when it's needed, construction companies using these AI monitors have successfully decreased their unscheduled equipment downtime by 25%. Artificial intelligence effectively acts as a localized immune system for the job site, taking a traditionally reactive environment and turning it into a self-correcting machine. Above the machinery, drones equipped with AI analytics provide a macro-level view of the entire operation. They continuously survey the active site and compare the physical progress directly against the original digital blueprint. Because managers receive real-time progress reports highlighting exactly what needs attention, they can make faster, more informed interventions. Sites utilizing this overhead monitoring see overall project management efficiency increase by 15%. This brings up an obvious question. Is this technology being deployed to replace human construction workers? The short answer is no. Artificial intelligence is unmatched at processing vast amounts of data and predicting patterns, but it lacks the dynamic problem-solving, immediate judgment, and physical craftsmanship required to build. You still need human teams working together to navigate the unpredictable realities of wet concrete and shifting terrain. AI functions as an augmentation tool, handling repetitive or data-heavy tasks so that human workers can apply their specialized skills and judgment where they are most needed. Adopting this technology does come with massive friction. The initial financial investment to integrate AI systems across a company is a staggering barrier for many legacy construction firms. Beyond the cost, there are steep operational hurdles. Companies have to undertake the massive job of retraining their entire workforce to use new tools, while simultaneously trying to force decades-old legacy IT systems to communicate with modern AI software. Then there are the hidden digital vulnerabilities. AI models are useless without flawless, consistent data quality to train on, and bringing entire construction sites online opens up a new threat vector for cybersecurity breaches. Realizing the benefits of an intelligent job site is not a quick fix. It requires a complete dismantling of organizational resistance and old habits. For those willing to adapt, the immediate technological horizon is remarkable. We are already seeing the testing of autonomous bulldozers that eliminate human error on the ground, and generative design software that maps out millions of highly optimized, eco-friendly architectural possibilities in a matter of seconds. Modern projects now utilize digital twins, living virtual replicas connected directly to the physical structures they represent, allowing engineers to continuously monitor and optimize a building's energy usage and performance long after construction ends. Still, the true future of this industry doesn't belong to the machines alone. It relies entirely on the fusion of skilled human expertise and these new intelligent systems working in tandem. The smartest builders operating today aren't just putting their money into larger cranes and heavier equipment. They are investing in intelligence, ensuring they have the capability to build the safest, most efficient structures of tomorrow.